All right, before we get started on Desmos, looking at the actual graphs of these 6 functions, it would be very helpful if you had in your notes a chart or a table with the 6 functions. Let me show you basically what we're going to put in here. We are going to create x, y coordinates so that we can plot the points so that we can draw the graphs. But again, we're going to draw the graphs on the computer in Desmos. They'll look a lot neater and a lot more like what they really look like. So what we have here is this. This first column is all of the input values. You'll note that they are all radian angle measures. Now, we normally start at 0 right here and we go up to 2 pi right here. Okay, so from here down to here are our regular angle measures that we're going to input. But I want to go back by 1 quadrant and forward by 1 quadrant as well. Meaning we're going to go backwards from 0 to negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So we're actually going to go to the negative side of the x-axis, okay, to the left of the y-axis, because a couple of these graphs start one quadrant backwards, okay? And some of them proceed 1 quadrant forward. So after we make the full circle and get to 7 pi over 4, 11 pi over 6, and then 2 pi, we're going to then continue into the next rotation of the unit circle, 13 pi over 6, 9 pi over 4, 7 pi over 3, and 5 pi over 2, okay? So what we have here is this is going to be quadrant 4, then quadrant 1 up to, well, I guess I should put it like this. Okay, so quadrant 4 goes to here, quadrant 1 goes to here, quadrant 2 to here, quadrant 3 to here, quadrant 4 to here, and then quadrant 1 again. So we'll go 4, 1, 2, 3, 4, and then quadrant 1 again, okay? And what we're going to do is we are going to create this chart, and I'd like to do this right now, only I'm going to probably go fast forward. And we want to we want to identify sine of negative pi over 2, sine of negative pi over 3, etc. Sine of 0, sine of pi over 3, pi over 6, sine of pi. So these are all going to be all of our output values of pi. These are going to be all of our values of cosine, tangent, cotangent, secant, and cosecant, okay? Now you've already done this before, but very simply what we're doing here is we're saying, for example, what is tangent of pi over 4? Well, we know that tangent of pi over 4 is 1. So in this box right here, we would put a 1, okay? And so what we're going to do now is we're going to fill in all 6 of these all 6 of these columns based on the input values of these angles, okay? So you go ahead and draw up this in your notes. You can probably use up a whole page if you need to. There are, including the top line here, I believe there are 26 rows, and then including the X column, there are 7 columns, okay? And what I'm going to do now is I'm going to go ahead and start filling in. I know that sine of negative pi over 2 is negative 1. And I know that sine of negative pi over 3, which is the same as sine of 5 pi over 3, that is negative square root of 3 over 2. And now I'm just going to continue, okay? Okay, so what you may want to do is now check your, maybe pause this and check your tables to my tables. You can see that they are, each one of these has its own pattern. In fact, you may have one of these somewhere in your notes back when you were learning the unit circle, okay? But what we're going to now do is we're going to pair them together. We're going to plot the points negative pi over 2 and negative 1, negative pi over 3 and negative square root of 3 over 2, negative pi over 4 and negative square root of 2 over 2. Now what I'd like to do though is, before we do that, because in Desmos, instead of showing negative square root of 2 over 2, it's going to show a decimal. And so what I'd like to do is, I'd like to go ahead and write out, do you see all these numbers here? That these are our most common irrational numbers that are in this table, right? We got square root of 2 over 2 and square root of 3 over 2 in sine and cosine. We got square root of 3 and square root of 3 over 3 in tangent and cotangent, and we have square root of 2 and 2 square root of 3 over 3 in secant and cosecant, okay? And so what I want you to do is, I want you to grab a calculator, and I want you to identify the decimal values of these six values. It may be rounded to the 4th decimal place, okay? So I'm going to go ahead and do that now. All right, so the reason we did this is, now what I want you to do is I want you to consider that everywhere that you see a square root of 2 over 2, like right here, you actually have the number 0.7071. And everywhere you see a negative square root of 2 over 2, you have the number negative 0.7071, because those are approximately the same number, okay? The last thing I want to say is, do you see all these places where it says undefined? Those are all places where there is a 0 in the denominator. Because cotangent is cosine over sine, well, whenever sine is equal to 0, cotangent is going to be undefined. And what I want to remind you is that when that happens, when you have 0 in the denominator, when you have 1 in the numerator and 0 in the denominator, you're going to have a vertical asymptote. So everywhere that you see one of these words undefined, on the graph, there's actually a vertical asymptote. And so that's what we're ultimately going to draw in on the graphs when we look at them, okay? All right, so you have your table. We're now going to see these tables. We're going to do one at a time. Sine, then cosine, then tangent, then cotangent, then secant and cosecant. And we're going to see all these 6 different shapes of these 6 different graphs. Okay, so what we're going to do is we're going to do the graph of sine here. And what I've done in Desmos is I've set up the function right here. And when I click on this circle, it'll actually show the graph. But for now, I have it hidden. What I want to do here is I want to enter the values in the table. Now for sine, we're only going to use, we're going to start at 0. Instead of starting at negative pi over 6, we can see the entire sine graph simply by starting at 0. So you can see now if I enter 0, it enters the output. On your table, you should see that when x is 0, sine of x is also 0. And look what it did here. It went ahead and plotted the point for us, okay? And so now the next one after 0, you'll see that the next angle measure is pi over 6. And when I enter pi over 6, it gives us 0.5, which is the same thing as 1/2. And you can see over here that it has plotted pi over 6 and 1/2. Now you may say, well, what is that? That's sort of in the middle of nowhere, right? Well, you'll see here, here's 1 right here, the height of 1, and here's 0. Well, it counts up 1, 2, 3, 4, 5. So this is 1/5, 2/5, 3/5, and 4/5. Well, 1/2 is halfway between 0 and 1, and that's right about here. And so this is 1/2. Now, what about this? Well, you can see here that we have some vertical lines here, and that this is pi over 2, right? Well, half of pi over 2 is pi over 4, so this one right here is pi over 4. And we know that right before pi over 4 is pi over 6. And so that's what you're seeing right here, is that this is pi over 6 right here, then this is pi over 4, and then over here, you're going to see pi over 3, and then this is pi over 2. So now, when we put in pi over 4 as our next point, it's going to be along this line right here, okay? And we know that the height is going to be square root of 2 over 2, which is actually 0.7071. And so what we have here is this is 0.2, 0.4, 0.6, and 0.7 right about here. Okay, so we're going to see right about here is going to be the next point. So let's go ahead and put in pi over 4, and you can see right there at pi over 4, it gave us a point at about 0.7. The next one is going to be at pi over 3, and we know that that is square root of 3 over 2, or 0.866. You can see right here it's 0.866, right? So here's pi over 3, and then it's 0.866 is much closer to 1. Now we know the last one at pi over 2 is going to be equal to 1, and there we go. So now we have pi over 2 at 1. So we've gone from 0 up to 1/2, square root of 2 over 2, square root of 3 over 2, and then 1. Now we know that from there we're now going to move on to 2 pi over 3, which is also going to be square root of 3 over 2, okay, which is over here. So look, it's at the same height right here as the other square root of 3 over 2. And we know the next one is going to be at 3 pi over 4, which has a height of square root of 2 over 2, which is at the same height as this one over here. And then we're going to have 5 pi over 6, which is 1/2, which is at the same height as this 1/2 over here. You can see these are at the same height. And we know that when we get to pi, that sine of pi is equal to 0, so it's going to have a point right over here. Okay, so now we're going to go to pi, and it gave us a point at 0. So we're halfway done with the sine graph, okay? Starts here at 0, 0. It goes up to 1 at kind of a curve. Then it comes back down to 0 at a curve. You can see that this is not a straight line, okay? If this was a straight line, this is what it would look like. It would look like y equals, not x, I'm sorry, y equals, let me get my pi over 2 up 1, yeah, okay. It would be pi over 2x, or sorry, where are we at, pi over 2? It would be, up 1, sorry, 1 over pi over 2 is what it would be, x. There we go. Okay, if it was a straight line, it would go from here through here, but you can see that because these 2 points, or 3 points, are above this straight line, that it is not a straight line between 0, 0, and then pi over 2 and 1. Okay, it is a curved line. All right, so we know that on the table, the next thing we'll see after pi is 7 pi over 6, which will give us negative 1/2, which is now down here because it's negative, right? All the rest of them are going to be down here because they're negative, right? Then we're going to have 5 pi over 4, which is negative square root of 2 over 2, or negative 0.7071. Then we're going to have 4 pi over 3, which is going to give us negative square root of 3 over 2. And then 3 pi over 2, which is going to give us negative 1, because sine of 3 pi over 2 is negative 1. Here's 3 pi over 2. Here's pi. Right on this line is 5 pi over 4. Then right about here is 7 pi over 6. And right about here is 4 pi over 3. Okay? All right, in fact, let me center this a little bit now. Okay. And now we're going to move on to the next part of the table is going to be 5 pi over 3. 5 pi over 3, which gives us this point right here. And we're going to go to 7 pi over 4 is at negative square root of 2 over 2. And then 11 pi over 6, which will give us negative 1/2. And then the last one is at 2 pi. We know that sine of 2 pi is equal to 0. We go back to the starting point. And so what you're going to see here now is that the graph of sine starts at 0, it curves up to 1, then it curves back down to 0, then it curves down to negative 1, and then it curves back up to 0. And so what we're now going to do is I'm going to activate the graph of sine of x, and you'll see a picture of the whole thing. So when I click this button, you'll see that, oops, why didn't it do that? I'm going to click on here. There we go. And you can see now the graph I'm gonna move this out of the way. You can now see that the graph of sine, it's a curvy line. In fact, it flattens out up here at 0. It curves up to 1, then it curves down to 0, then it curves down to -1, and it curves up, back up to 0. Now remember how we said that these trigonometric functions, as you go to positive infinity, they just continue? Well, I'm going to zoom out here just a little bit, and you'll see that as we go to negative infinity and to positive infinity, we just see the same curve over and over. Now it starts at 0, goes up, down, and up. And so the next one, up to 4 pi, goes up, down, up. Then up to 6 pi goes up, down, up. And then it'll continue up, down, up. And then going backwards, it does the exact same thing. Only from 0, it's going to be the opposite. It's going to go down, up, down, down, up, down. But if we were to start at -8 pi here, we see up, down, up, then up, down, up, then up, down, up, then up, down, up. And that's what the sine curve does. This is called a sine wave. Okay? Now let's move on to the cosine wave. Okay, so now let's do the exact same thing with cosine. We're going to activate the graph so we can see the whole thing after we have plotted some points. So here, this is going to be cosine. We know that at 0, we're going to do the exact same thing with cosine that we did with sine. We're going to start at 0 and go up to 2 pi because we can see the entire curve just from 0 to 2 pi. So at 0, we know that cosine is equal to 1, and so we have this point. You can see the point 0 and 1 is plotted right up here at 0 and 1. Again, we're broken up into radians, up to pi, up to 2 pi here. We know that halfway from here to pi over 2, we're going to see pi over 4. And we're going to see pi over 6 right about here. So the next one is pi over 6, and we're going to have square root of 3 over 2. And so we got pi over 6 and square root of 3 over 2. Then we're going to have pi over 4, and that's going to be square root of 2 over 2. Then we're going to do pi over 3, and that's going to give us 1/2. And then, of course, at pi over 2, cosine is equal to 0. And so whereas sine started at 0, 0 and curved up to 1, to pi over 2 and 1, cosine starts at 0, 1 and curves down to pi over 2 and 0. So it starts at 1 and curves down to 0. So now we're going to move on to 2 pi over 3, which will give us -1/2. Then 3 pi over 4, and that'll give us negative square root of 2 over 2. And then we'll go to 5 pi over 6, which will give us negative square root of 3 over 2. And then we'll go to pi, which gives us -1. And so you can see that cosine is starting at 1, curving down to 0, and then curving down to -1. Okay? And then what it's going to do from -1 is it's going to curve up to 0 and then curve up to 1 again. Okay? So we're halfway done. Now let's move on to 7 pi over 6. Okay, again, we have negative square root of 3 over 2, which is -0.866. That's this point right here. Then at 5 pi over 4, we're going to see the same thing as this over here, negative square root of 2 over 2, only it's going to be right over here. Okay, so 5 pi over 4. And then we're going to go to 4 pi over 3, which will give us -1/2. And then, of course, at 3 pi over 2, we'll have 0. 3 pi over 2 gives us 0. So we have 3 pi over 2 and 0. So we curved from 1 down to 0, then 0 down to -1, then from -1 up to 0. And now the last part, we're going to have 5 pi over 3, which is going to be at 1/2. Then 7 pi over 4, which is going to be at square root of 2 over 2, right here. And then 11 pi over 6 is going to be at square root of 3 over 2. And then once we get to 2 pi, we are at 1. And so you can see that cosine is a little different than sine, where sine goes up, then down, then up. Cosine starts all the way up and just goes down and then up. Okay? So sine gives us like an N shape, and cosine gives us like a V shape, okay? Now we're going to look at the full graph of cosine. So click here and we'll fill it in. And you can see that there it is. There's the curve of cosine, filling in, connecting all the dots at a curve. Now, you may think to yourself, wow, cosine looks a lot like sine. It is. It's also a sine wave. Cosine is a sine wave. In fact, it is the same as sine, just shifted to the right a little bit, okay? So if we zoom out here, you can see that just like sine goes up, down, up, down, up, down, up, down, up, down, up, down, cosine does the exact same thing. Only cosine starts at 1 at the y-axis, starts at 1, and then curves down to -1 and then up to +1. Down to -1, up to +1. Down to -1, up to +1. Down to -1, up to +1. Even on the negative side here, it's down to -1, up to +1. Down to -1, up to +1. And it does that all the way to positive infinity and all the way backwards to negative infinity. Okay? Now what I want to do is I just want to show you, what happens if we can see the sine graph at the same time. I'm going to turn off this, and I'm going to put in y equals sine of x, and I'm going to change the color to red like it was before. And you can see now, we can see both the sine and the cosine waves right next to each other. Okay? Now the fact that they look very similar, they go in the same pattern, 0 to 1, down to 0, down to -1, up to 0. We could say the same thing about cosine, only look, cosine is shifted. It starts where sine is backwards here at -π/2. So if we looked at this spot, 0, 0 for sine, but we go -π/2, we would see that cosine starts at the exact same place, goes up, down, then up again. And do you remember the identity that sine is equal to cosine? Sine of theta is equal to cosine of theta, but minus π/2, okay? And that is the cofunction, one of the cofunction identities. And so basically, if we shift sine backwards by π/2, we grab the whole curve and shift it backwards π/2, we would have cosine, okay? And so that's the graph of cosine. And now what we're going to do is we're going to move on to the graphs of tangent, cotangent, secant, and cosecant. All right, so now let's graph tangent, okay? Now tangent, we're going to have to go all the way back to -π/2, and we're going to want to go up to 5π/2, okay? So let's go ahead and enter these values from the table. We'll start with -π/2, and we can see that it's undefined, okay? Now remember what I said, that when a graph is undefined, there is a vertical asymptote. So what I'm going to put in here is, to put in a vertical asymptote, we're going to put x equals. And we're going to put in x equals -π/2, and I'm going to make it a dashed line like this, and I'm going to make it I think I'm going to make it orange, okay? All right, so what you can see here is a vertical asymptote. So tangent has a vertical asymptote at -π/2. Okay, so now let's move on to -π/3. Has a point at -√3, which √3 is 1.7321, so this would be -1.7321, which you see right here, okay? And so that's this point right here, -1.73 at -π/3. So now if we go to -π/4, I'm just going right off the table that's in front of you. Our output is -1, so at -π/4, we're at -1. Then we'll go to -π/6, which will give us square root of 3, square root of 3 over 3, but it's negative. And so this is negative square root of 3 over 3, which is the same thing as 0.5774. And so you can see in the graph here, this is 5774, okay, or negative 0.5774. All right, then when we go to 0, tangent is 0. So we have the point 0, 0. So you can see here, the graph starts here, but it's not really here. It actually goes all the way to the asymptote. What I want to remind you about an asymptote is that an asymptote causes the graph to go to infinity or negative infinity. So it looks to me like here the graph is going to negative infinity, okay? And then it goes up to 0 here, and now we're going to go to pi over 6. And look, that now gives us positive square root of 3 over 3, okay? Which is positive 0.774. Then we're going to go to pi over 4, which is going to give us 1, which is right here, okay? Then we're going to go to pi over 3, which is going to give us square root of 3, which is 1.732. That's up here. And we know that at pi over 2 that it is undefined. Therefore, we have another vertical asymptote at pi over 2. So we're going to, I wonder if I can put in here equals pi over 2. Nope, not going to let me do that. I'm going to have to do a brand new one. So now I have to do x equals pi over 2. And I need to modify that. I'll make it orange again, and I'll make it dashed. There we go. And so now we have another vertical asymptote, okay? So here's what we're looking at. It looks like it follows an asymptote here. It goes through this point, through this point, through this point, through 0, 0, then through this point, then it curves upward, through this point, and then it must follow the asymptote up here, okay? All right, well, let's move on now then to 2 pi over 3, and it looks to me like we've got negative square root of 3 again, which is down here, okay? And it's very likely, see, that's the same as this over here. It's very likely that we might then see this point again at negative 1. Well, sure enough, 3 pi over 4 gives us negative 1, and then 5 pi over 6 gives us negative square root of 3 over 3, and then pi gives us 0. So look what we're seeing. We are seeing a repeat of this pattern right here. Chances are we're going to see these 3 points right over here again, and then probably another vertical asymptote. All right, so let's go to 7 pi over 6. Sure enough, there's our positive square root of 3 over 3. Then our 5 pi over 4 is going to give us 1. And then our 4 pi over 3 is going to give us positive square root of 3. And then our 3 pi over 2, once again, is undefined. And therefore, we need another vertical asymptote at x equals equals 3 pi over 2. Again, we're going to make it orange, and we're going to make it dashed. There we go. And so you can see here 2 iterations of this pattern right here. And remember, we're going out to 5 pi over 2, so let's see what happens again. After 3 pi over 2, we have 5 pi over 3, which gives us down here again negative square root of 3. Then we're going to have 7 pi over 4, which gives us negative 1. Then 11 pi over 6, which once again gives us negative square root of 3 over 3. Then we go to 2 pi and we get 0. Looks like we're seeing the exact same pattern again. Then, last few we have here are 13 pi over 6, which gives us positive square root of 3 over 3 again. 9 pi over 4 gives us positive 1 again. And then 7 pi over 3, once again, gives us positive square root of 3. And then when we get to 5 pi over 2, once again, we're undefined, so we need one more vertical asymptote here. X equals equals 5 pi over 2. And then we're going to make that dashed and orange and done. And what you're seeing here now is you can see the same pattern starting at negative pi over 2 and all the way up to 5 pi over 2. We have this pattern over and over that is separated by vertical asymptotes. So now what we're going to do is we're going to go ahead and activate the graph of tangent of x so that we can see what it looks like. So if I click on that, there we go. And if I move this out of the way on the left, you can see, and if I zoom out, you can see that this is the graph of tangent of x. What it does is, over and over and over again, it just does this negative infinity vertical asymptote, then it curves to go through 0, then it curves back up to go to a positive asymptote, and then on the other side of this undefined point, it again starts at negative infinity, curves up to go through 0. By the way, it goes through negative 1, then 0, then positive 1, then it curves back up to go to positive infinity. And it does it all the way, it does it over again and over again and over again through positive infinity and through negative infinity. What you are looking at here is the graph of tangent, okay? And what I'm going to do is I'm going to take out the points, and I'll also take out the asymptotes so that you can actually see what it would look like if you only graphed just the graph of tangent of x, okay? This is tangent of x, and if we zoom out, you can see that it goes to negative infinity and positive infinity. This is the graph of tangent of x. Okay, now we're going to do the graph of cotangent of x. Now, cotangent we can do between 0 and 2 pi. We don't have to start at negative pi over 2. All right, so for cotangent, here we got our table. We've got our graph ready to go, but we haven't clicked on it. We don't want to see what it looks like yet. Let's go ahead and start at 0. So at 0, cotangent is, let me click this here. At 0, cotangent is undefined. And that means there is a vertical asymptote. So let's go ahead and put in a vertical asymptote at 0. Okay. And I don't know why it is, oh, there we go. Turn it on. There we go. So we have a vertical asymptote at 0. And so now let's go ahead with our next point. Cotangent of pi over 6 is square root of 3. So pi over 6, there we go, square root of 3. Which we know that's positive square root of 3, so it's about 1.7321, right? Then we're going to do pi over 4, and we get 1, which is right here. Now, something interesting is happening here. We just did tangent. Tangent started at negative and went to 0 and then went to the highest positives. This one looks like it's starting at its larger numbers, and the numbers are getting smaller, because this is now 1, and now when we go to pi over 6, you can, or pi over 3, excuse me, you can see now we're at square root of 3 over 3. And so our numbers are getting smaller. I'll bet you our next number is 0. Well, I know it is because I'm looking at the table right now. And cotangent of pi over 2, sure enough, is 0. Okay? And so here's our point 0. So now, instead of starting at the negative, we've got a vertical asymptote at 0. So we're starting up at the positive, and we're curving down along the asymptote. Then we're going to curve into these larger numbers, and we're going to curve towards 0. Okay, well, let's see what happens at 2 pi over 3. Okay, at 2 pi over 3, we have negative square root of 3 over 3, which is down here. Then at 3 pi over 4, of course, we have negative 1, which is down here. And at 5 pi over 6, we have negative square root of 3, which is down here. And then when we get to pi, we have another undefined, which means we have another vertical asymptote, but this one is at pi. Okay? Just go ahead and hit there. All right, so let's look at this for a second. We've got a very similar shape to tangent, only it's sort of inverted. And there's a reason it's inverted, because cotangent is the reciprocal of tangent, right? Okay, so it's not a perfect inverse, but it is kind of a backwards thing. So we've got our curve starting at positive infinity, coming down, going through this point, then this point, then this point, then 0, then negative 1, then negative square root of 3, and then it's going to go to this vertical asymptote here, okay? All right, well, let's see what happens at 7 pi over 6. 7 pi over 6, once again, gives us square root of 3, which is up here. It's on par with this again. So I'm wondering if we're going to see the exact same pattern again that we just saw, just like we saw a repeated pattern with tangent. Let's go to 5 pi over 4, and sure enough, we've got a positive 1. Then at 4 pi over 3, we got square root of 3 over 3. And then at 3 pi over 2, we have 0. And so it looks like we're seeing that same pattern again. Now, when we go to 5 pi over 3, I'll bet we get a negative. Sure enough, we get negative square root of 3 over 3. Then 7 pi over 4 gives us a negative 1. And 11 pi over 6 gives us negative square root of 3. And then when we get to 2 pi, we once again have undefined. So we're gonna put in another vertical asymptote here, only at 2 pi, and there it is. Okay, so it looks like we're seeing with cotangent a very similar pattern with tangent, only it's kind of upside down and it's also shifted over, because tangent actually didn't have a vertical asymptote at 0. It had a vertical asymptote at pi over 2 and at negative pi over 2. Okay,
And so let's go ahead and graph this cotangent. If we turn on the graph, look what we see. It's exactly what we expected. If we zoom out here, you can see, once again, over and over again, we have this time it starts at the positive side of the vertical asymptote, and then it goes negative, and then ends going to negative infinity at the vertical asymptote. Okay, so let's see what this looks like if we throw tangent on here. So let's go ahead with y equals tangent of x, and tangent of x is in green. And I'm going to move this out of the way, and you can see here, see how tangent of x is crossing over the vertical asymptotes for cotangent, okay? And it's intersecting, look, it's intersecting at the ones and the negative ones, okay? And so this is very interesting, where tangent goes up over up, cotangent goes down over down. But both of them are dealing with vertical asymptotes, okay? So let's go ahead and get rid of tangent here so we can see this again. I'm going to get rid of the vertical asymptotes. I'm going to get rid of the dots so that we can see just the graph of cotangent. And you can see the graph of cotangent goes from negative infinity to positive infinity over and over and over again. It's vertical asymptote from the positive, coming down from positive infinity, then over, crossing zero, and then going down to negative infinity, and then doing it over and over again, repeatedly, all the way through x values, angle measures of positive infinity, okay? All right, so that's it for cotangent of x. Now let's move on to secant of x. All right, now we're going to do the graph of secant of x. Okay, now for secant, we're going to have to start back at negative pi over 2 because there is an undefined point there. Okay, that's a good starting point. So let's go ahead and we'll activate the dots, and we'll put in negative pi over 2, and you can see that it is undefined. Therefore, we need a vertical asymptote at negative pi over 2. We'll activate that. And so you can see this vertical dashed green line here indicating a vertical asymptote, an undefined point for secant of x. Now remember, secant of x is related to cosine, okay? It's 1 over cosine. And so now we're going to go to, from negative pi over 2, we're going to go to negative pi over 3. And you can see this is our point up here at 2, okay? And then we're going to go to negative pi over 4, and we're at square root of 2, which is 1.4142. And then we'll go to negative pi over 6, which is going to give us 2 square root of 3 over 3, which is the same thing as 1.1547. And so you can see a nice curve here. Now we know that we've got a vertical asymptote here, so it's very likely that what's happening is that this is coming from the positive infinity at negative pi over 2. We're probably at positive infinity here, coming down along the asymptote, then coming out to connect with this point, then this point, then this point. And now we know that at 0, secant is equal to 1, just like cosine is equal to 1, okay? Then from 0, we'll go to pi over 6, and now we're going back up to 2 square root of 3 over 3. Then at pi over 4, we're going up again to square root of 2. And then at pi over 3, we are going up to 2 again. And look at this, we got this nice kind of this bowl shape here, right? Okay, but we know that it's coming from this asymptote, so it's coming down here, and then it's creating this bowl-shaped turnaround. And then we already know what's going to happen at pi over 2. We have another undefined point, which means we have another vertical asymptote at pi over 2. All right, so we'll put that in right there. So we can see probably what's happening here is the bowl is coming down from here, then it's turning around, and then it's going to go up and follow the asymptote up. So where with tangent and cotangent, it, let's say, came from the top and went to the bottom, or came from the bottom and went to the top, this one is actually coming from the top and going back up to the top the other direction, okay? All right, so maybe what we'll see is a pattern of a bunch of U-shapes over and over and over again, okay? All right, well, let's move on now here to 7 pi over 6, or excuse me, to 2 pi over 3. And that gives us, oh, it gives us negative 2. Okay, wait a minute. So instead of being up here, we're now down here. Okay? All right, well, then we're going to go to 3 pi over 4, which is at negative square root of 2, which is right here. Okay, so now what I'm seeing is I'm seeing our vertical asymptote here. It must be coming up from the bottom and going to here and then here. And then when we get to 5 pi over 6, yep, sure enough, it's leveling off. Now this one was at positive 1 over here. I wonder if this one's going to wind up at negative 1. Oh, look at the table. It sure does end up at negative 1 because secant of pi is negative 1. And so now let's move on to 7 pi over 6. And sure enough, now we're going back down to negative 2 square root of 3 over 3. Then 5 pi over 4 gives us negative square root of 2. And then at 4 pi over 3 gives us negative 2. And then at 3 pi over 2, we get another vertical asymptote. Okay? So we'll put this one at 3 pi over 2. And here we go. All right, so for this one, we're actually seeing that we're coming from the bottom and then going up and making a hill shape, turning around and going back to the negative. All right, so I'm seeing that over here, it starts out at the top, then it comes down, curves back up, and goes back up to infinity. Then it starts at negative infinity and goes up, curves over, and goes back down to negative infinity. What do you bet on this next one? On the other side, we probably see a positive infinity that comes down and goes back up to positive infinity again. Okay? All right, well, we'll only know if we put in 5 pi over 3. There we go. And sure enough, we get a positive 2, which is right here. That's mirroring this one over here. Then we'll put in a 7 pi over 4. Sure enough, we're mirroring this point. It's right here. Then we'll put in 11 pi over 6. And sure enough, there's our next point. And we know that at 2 pi, secant of 2 pi is 1. So we're seeing the exact same shape that we saw over here. Okay, we're seeing a repeat. So we're seeing a pattern. The next one is going to be 13 pi over 6, which is positive 2 square root of 3 over 3. Then 9 pi over 4 is going to give us positive square root of 2 again. A couple more here. It's going to be 7 pi over 3, gives us positive 2 again. We definitely have a mirror image of what we had over here. And now when we get to 5 pi over 2, once again, we have an undefined, so we have another vertical asymptote. We'll put that in right there. There it is. Oops, shouldn't have zoomed in like that. And now, so we're seeing vertical asymptote, turn around, then back up. Vertical asymptote from the negative, turn around and back down. Vertical asymptote coming down from the top, turning around and going back up. And so let's go ahead and hit our cosecant, or our secant function. And when we fill in, look at that. Sure enough, it fills in those points. And now I'm going to move this over and zoom out, and we can see, sure enough, here's our secant pattern over and over and over again. From negative infinity up to positive infinity, we have a top curve that turns around, and then a bottom curve that comes up and curves around. Then it comes from the top, then it comes from the bottom, then it comes from the top, then it comes from the bottom. And it looks like the vertical asymptotes are separated by one pi, but on the half pi increments. So we start at negative pi over 2, then add 1 pi, and we get pi over 2, another vertical asymptote. Add 1 pi, we get 3 pi over 2, another vertical asymptote. Add 1 pi, and we're at 5 pi over 2. The next one's going to be at 7 pi over 2, then 9 pi over 2, then 11 pi over 2. What we have here is just an infinite number of vertical asymptotes separated by these curves on the top, curve on the top, curve on the bottom, curve on the top, curve on the bottom. Now, I do want to show you something really interesting now. I'm going to remove the dots, and I'm also going to remove the vertical asymptotes. And I'm going to put in cosine and show you something really neat. I'm going to put in y is equal to cosine of x, and check this out. where cosine goes from -1 up to 1 and back down to -1, so the maximum of cosine is 1 and the minimum of cosine is -1, we have the secant points. Where secant reaches its lowest point, it meets up at cosine at 1. And then after the next vertical asymptote, where secant meets its highest point, it meets up at cosine at -1. And this is going to happen all the way through infinity. Okay? So cosine basically connects the secant points. So you know that wherever cosine is equal to 1, which is where cosine starts, you know that secant is also going to be equal to 1 there. And wherever cosine is equal to -1, secant is also going to be equal to -1. Okay? All right, so we only have one graph left. We're going to do cosecant, and we know that that is related to sine. Okay, so now let's look at the graph of cosecant. Now for cosecant, we can start at 0 because that is where one of its undefined points is. Okay? So when we put in 0, we see that cosecant is undefined. And so we can go ahead and put in a vertical asymptote at 0. Okay? And so at 0, we got a vertical asymptote. Now we're going to move on to pi over 6. And we know that at pi over 6, it has a value of 2. Well, we've seen this before. This looks very familiar. Now let's go to pi over 4. And we have square root of 2. And then we have pi over 3. And we have 2 square root of 3 over 3. In fact, if you look at your tables, I want you to compare secant to cosecant, where secant starts at -pi over 2. And cosecant starts at 0. And as you go up in one increment each time, you can see that cosecant matches secant, but it's off by pi over 2. Okay? And that is because there is a relationship. Just like there's a relationship between sine and cosine that's separated by pi over 2, there's also a relationship between secant and cosecant that's separated by pi over 2. So just like secant started at positive infinity and then came down and went through 2, then square root of 2, then 2 square root of 3 over 3, and then what did it go to? It went through 1, right? So pi over 2, sure enough, there's 1. We've got this same kind of downward and then bowl shape again. We're going to see the same pattern here that we saw in secant, only instead of starting at -pi over 2, we're starting at 0, okay? And so now let's go ahead and put in 2 pi over 3, and sure enough, it's changing direction. Then we'll put in our 3 pi over 4, and yep, it's curving back up. You can see it just like secant curved back up. And then 5 pi over 6, curving back up, and then at pi, there it's undefined, so we know we're going to have a vertical asymptote at pi. All right, there we go. So this looks exactly like secant, except that secant was started over here, and it did its bowl shape like this, okay? So we're phasing over by half a pi, and we're doing the exact same shape. So now what I'm expecting to happen over here is I'm expecting it to come from the bottom and go up and over to 2 pi. All right, well, let's see if that actually happens. All right, so we'll now go to 7 pi over 6. And sure enough, here we are down at -2. Then we're going to go to 5 pi over 4. And sure enough, we're at negative square root of 2. And then 4 pi over 3, once again, gives us -2 square root of 3 over 3. And I'll bet 3 pi over 2 gives us -1. And sure enough, there's -1. And then we'll go to 5 pi over 3, which once again gives us -2 square root of 3 over 3. Then 7 pi over 4 gives us, once again, negative square root of 2. And then 11 pi over 6 gives us -2 again. And then we know that at 2 pi there will be a vertical asymptote. Okay? Just go ahead and put that in at 2 pi. And here is our pattern for cosecant. Okay? So let's go ahead and fill in the graph. Boom. And there we go. And if we zoom out, you can see, once again, cosecant is just like secant in that it has this down then up, and then up then down. Okay, down then up, and then up then down. Now, Just so you know that it's not identical to secant, let's go ahead and put in the graph of secant, y equals secant of x, and you can see that secant of x, let's change the color there, let's make secant of x red. All right, you can see that secant of x is shifted over from where cosecant of x is. So what you have to understand is that, let's look here. Secant of x hits its low point on the first curve here, goes down to 1 when x is equal to 0. But cosecant comes down to 1 where x is equal to pi over 2. And there's a good reason for that, because cosecant is related to sine. So now if we go ahead and put in the graph of sine, let's change the secant to sine, you can see that just like cosine touches the low points and the high points of secant, sine, whenever sine is equal to 1, cosecant is also equal to 1. And wherever sine is equal to -1, cosecant is also equal to -1. And that goes on to positive infinity, and it also goes on to negative infinity. So you can tell cosecant and secant apart by where they hit 1 and where they hit -1. Cosecant hits where sine hits 1 and where sine hits -1. And then going back here, let's change it now. We're going to turn this one off and this one off. It's where, and secant is related to cosine. So I put in y equals cosine of x and y equals secant of x. You can see that it's happening in different places. But wherever cosine reaches 1, that's where secant equals 1. And wherever cosine hits -1, that's where secant hits -1. Okay? All right, so this is just the basic introduction to the graphs, the 6 graphs of the 6 trigonometric functions. And what I'm going to do now is I'm just going to do a brief summary where I put all 6 graphs in and show you them one at a time. Okay, so we're just going to review these 6 different curves, these 6 shapes. Okay? And I have them in order here. So sine looks like this. Turn on sine. Sine starts at 0 at the y. This is the y-axis. This is the x-axis. Starts at 0 and goes up, down, then up, and stops at 2 pi at the exact same place that it started. Okay? I started at 0. All right? So now cosine looks very similar, but instead of starting at 0, it starts up at 1, then it goes down to -1, and then goes back up to 1. So when it gets to 2 pi, it's at the exact same place that it started at 0. In fact, all of them are going to be like that. Okay? Starts at 1, goes down, and then back up to 1. That's cosine. Tangent has this curvy shape where it goes up, then over, then up, starts at -infinity, goes up, then through 0, then up to positive infinity. Then it goes up, then through pi, then up to positive infinity. Then it starts at -infinity again, goes up through 2 pi, then up to positive infinity over and over and over again. Cotangent does something very similar, but instead it starts at positive infinity and comes down and goes down to -infinity. And instead of hitting 0 at 0, pi, and 2 pi, it hits 0 at pi over 2, 3 pi over 2, and 5 pi over 2. Okay? Then secant and cosecant have a very similar shape. They have the down then up, and then the up and then down. So down under, then up over, then down under. But the big difference here is this, is that secant hits 1 and -1 wherever cosine hits 1 and -1. Whereas cosecant has the exact same shape as secant, only it's shifted over by half a pi. And it hits 1 and -1 wherever sine hits 1 and -1. Okay? All right, so that's it. These are the 6 basic graphs of trigonometric functions. The last thing we're going to do is we are going to look at what we call transformations of sine and cosine.